So we'll start from here. Now, as I said before, combined maths is a combination of, so combined maths is the combination of applied maths and pure maths. So we have discussed this since it's around 2 months after starting the classes. So we have discussed this very well. So combined maths has two parts, applied and pure. Now the pure section, we have started the first lesson. It's not the first lesson, but anyway we have started polynomials and we are like halfway through it. And today we are starting the first lesson of vectors. First lesson of vectors. So that is applied. So now you all would be, now for us maths is basically no level, maths is basically pure maths. We don't have any applied sections in, we don't have applied parts in maths, oral maths. No. For example, you don't have forces, VT graph, we have VT graph in oral maths, right? Yeah, so basically oral maths is more towards pure maths rather than applied maths. So I'm starting vectors a bit earlier. Now most of the tutors are not starting vectors now itself. They would be waiting till they finish trigonometry. But I would be starting vectors now itself so that you can get a rough idea what applied is. Okay? Right. So the vectors lesson, it's something like this. Now I have explained you the structure of the paper. So we get 10 structured questions. In our paper we have 10 structured questions where you have to answer all the questions, and we have 7 essay questions where you can select 5. So in the applied paper we have 1 structured question from vectors and 1 essay question from vectors. I guess it's the 14th question, part A is from vectors. So we have a structured question as well as a essay question in this lesson. Apart from that, vectors is applied in forces and in other applied lessons too. So vectors is very important, the first lesson of applied, so we'll move through it. Just write the main topic, vectors. What's the school? Sorry? Sandun. Right, so we'll take the new book if you have the new book. If you don't have the new book, you can take the old book, that's fine. Anyways, take a book, that's it. Right, we'll write the main topic, vectors. In that, we'll write the main topic, vectors. Right, so we'll start from here. Now I would be giving you, or rather writing few quantities here. For example, I can say the duration of today's class is around 4 hours and the length of this board is 10 meters. That's not so long, but we'll consider it's 10 meters. And we can say the age of a person is 18 years old and the mass of someone is 50 kilograms. So these are few quantities. Now in these quantities we have a magnitude and a unit for that. Fine, right? Apart from that, I can write another example for quantities like a man walking towards north with a velocity of 10 meters per second. So velocity is a quantity too, right? A man travels towards east, a displacement of 100 meters. A wind is blowing towards south with an acceleration of 2 ms minus 2. Okay, so here I have 4 quantities and here I have 3 quantities. Both of them have magnitude and a unit, But we know there is a major difference between these 4 quantities and these 3 quantities. Are you all okay with that? We see major 2 differences between these. So what are the differences you see this? The similarities and the differences. What are the similarities you see here? If both of them has a magnitude and a unit 2. Apart from that, what are the differences we see here? This has a direction. Now for the duration of the class, do we need a direction for that? No, well, you don't have a direction of that. The length of the board, either I can start measuring from this end to that end or else from that end to this. Does that matter about the length? The direction of measuring? No, that doesn't mind. But this, a person walking, now for example, now if you move out of Shakti, when you come to the main road, someone walks towards Colombo 100 meters and the other person moves in the opposite direction 100 meters. So are these the same or different? It's different. No? So this fellow would be ending up somewhere around Kalpiti and this fellow somewhere around Vellavatta. Fine, right? So the direction minds here. And in these quantities, the direction, we don't care about the direction. Fine, right? So quantities can be separated into two types. We call these as scalar quantities, where we have only a magnitude. And we call these as vector quantities, where we have a magnitude and a direction. Fine, right? So after writing the main topic, just write quantities. Just in the middle of the page, write quantities. And separate it into two types. Scalar quantities and vector quantities. Quantities, scalar quantities, type 1, and vector quantities, type 2. Right. So under scalar quantities, we'll write quantities with only a magnitude. Quantities with only a magnitude is called, quantities with only a magnitude is called scalar quantities. Scalar quantities. And the next, under vector quantities, quantities with both magnitude and direction. Quantities with both magnitude and direction are called, quantities with both magnitude and direction are called vector quantities. Quantities with both magnitude and direction are called vector quantities. Okay, so under scalar quantities, we'll write the examples: duration of the class, length, not only the class, just write duration 4 hours, length 10 meters, age 18 years, mass 50 kilograms. And under vector quantities, we can write velocity 10 meters per second, displacement 100 meters, acceleration 2 ms minus 2, and also we'll write a force 14 newtons. Force 14 newtons. Fine, right? Okay. Right. So here we discuss, now we are going to keep aside the scalar quantities because our lesson is vector quantities. Right. So here, now look into the board. So here I wrote 5 examples of vector quantities, rather 4 examples of vector quantities. The first one is velocity, the second one is displacement, the third is acceleration, and the fourth is a force. Okay, so these are a few examples of vector quantities. Now keep in mind, all these are called vector quantities. But in maths what we do is we don't look into the quantity part, we just study about the vector. Which means we are not specifying whether it's an acceleration or a displacement or a force or a velocity. We just write it's a vector, that's it. We don't care about what type of vector that is. You all get to that. So in physics you all go deep into what is known as velocity, what is acceleration, what is displacement, what is a force. So in physics we study each and every quantity separately, but in maths we don't study about the quantities, we just study about the vector part. The part of vector. Fine, right? So in the vector lesson we don't have any units because we are not studying about the quantity, it's just the vector. Are you all okay with that? Understood, right? Okay, we'll write a subtopic: representation of vectors. representation of vectors. Representation of vectors. Okay. So now we studied vectors has a magnitude and a direction. Vectors has both magnitude and a direction. Fine. Right. Now if we are representing a vector, we must have a method of representing the magnitude and also the direction. Are you okay with that? So vector means we should have a magnitude and a direction. So in representing a vector, you should have a method of representing the magnitude and the direction. So this is what we do. For example, we consider 2 points A and B, and I call this AB a vector. I call this AB a vector. So if AB is a vector, we write it like this. The vector AB. This is the vector AB. Now in O levels, you all did something like this. No? The length of the line AB is 10 centimeters. And what you do is, right, you just draw that line. You call this A and B. Okay, this is 10. You measure 10 centimeters, right? This is 10 centimeters. Okay. So someone can do like this, and the other one, another person can name it like this. AB 10 centimeters. Is this correct or wrong? Both of them are fine because we don't care about the direction, so it's just the length. But here, since it's the AB vector, the arrow should be from A to B, this way. Now can I write it as BA? No, that cannot be done because we are talking about the vector A to B, the vector from A to B, which is called the AB. Okay, so when I started, I said a vector must have a magnitude and a direction. A vector must have a magnitude and a direction. So in this representation, by the direction of the line AB, by the direction of the line AB, direction of the line AB represent the direction of the vector AB. Are you okay with that? For example, now understand, we have a line PQ. We have a line PQ which is vertical. Then what must be the direction of the vector PQ? The direction of the vector PQ? It should be vertical. Why? The line PQ is vertical. Are you okay with that? Another example. We have a line M and N which is horizontal. Then what must be the direction of the vector Mn? Horizontal. Because the line Mn is horizontal. The direction of the line is horizontal. So the vector Mn must be horizontal. It's so simple. Fine, right? Okay, so what we say is the direction of the line represents the direction of the vector, point 1. And the second point is the length of the line. The length of the line represents the magnitude of the vector. Are you okay with that? For example, now see, we have a vector PQ and vector ST. Both of them are vertical, which means both of them have the same direction. But is the magnitude of PQ and ST equal to each other? No. ST is much more larger than PQ. Are you fine with that? Okay. So what we say is the length of the line represents the magnitude of the vector, and the direction of the line represents the direction of the vector. Are you okay with that? Right. So apart from that, we have another thing to study here. Now when typing, for example, in Microsoft Office and in WhatsApp also we have that option. We can bold a letter. So in WhatsApp, of course, we are use these stars, then the letter gets bold. Okay. Now consider an equation 3a plus 1 equals to 7. Now in algebra also we use these simple letters, and in vectors also we use those simple letters. Now there must be a specific way to classify vectors and these algebraic letters, right? So here also we use the simple A, and in vectors also we use simple A. So what they did was they used the bold simple A. They used the bold simple A to represent vectors. Okay. Now the problem we have is, can we do this when we are writing? Bold kar into blue. Now we do that when we don't know the answer. So just to spend the time, we bold the letters. That is something different. Apart from that, we can't do that. No. But if you look into the past papers and into your textbooks, you see they have bold this. Okay. So what we do is we can't do that. Instead of that, we just draw a line under the under the letter. Okay, so which means the vector AB equals to simple A. Are you okay with that? So this is the notation of vectors. Fine, right? Okay, we'll write below the subordinate representation of vectors. Below that, part 1, geometric representation of vectors. Geometric representation of vectors. Right. Just draw this line, that's it. Don't write anything else. Just draw this line. Okay. So below that you can write the direction of the line AB, the direction of the line capital AB represent the direction of the vector AB. So just write AB in the vector form. Represent the direction of the vector AB. This, okay? Okay. And the next point, the length of the line AB. The length of the line AB represent the magnitude of the vector AB. Represent the magnitude of the vector AB. Right. So this is the geometric represent, which means we drew a diagram and represented the vector. And the other thing is the algebraic representation of vectors. So now see here, this vector, the vector simple A is from point capital A to capital B. So algebraically we write it from A to B, the vector is simple A. Another example, we have 2 points P and Q. This is the point Q and this is the point P. We have vector from P to Q as called as B. Then what must be the algebraic representation of this? PQ equals to simple P. Fine, right? Okay, just write the next topic. Algebraic representation of vectors. Algebraic representation of vectors. Okay. Write this below that, write this, right? AB equals to simple A. Below that, right? AB equals to simple A. Right. We wrote. Right. So write this down also. So this is the vector PQ. From P to Q, we have the vector B. Vector PQ from P to Q. Just write. I'll write a few examples. Write the algebraic representation of those vectors. Okay. Right. So write this example and thereafter MN. This is called simple N, and we have BC, this is called simple C, and we have PR, this is simple E. Write this in the algebraic notation. Right, so we'll copy these examples 1, 2, 3 and 4. Okay, so here we can write the vector BC is simple C, the vector PR is simply the vector NM is simple N, the vector NM is simple N. Are we okay with that? Fine, right? Right, so we'll move on to the next. Write the topic, addition of vectors. Addition of vectors. Addition of vectors. Right, so this lesson vectors is very easy. For example, if you are able to go home after finishing the class. Now for example, we'll think someone is around Kalaniya. So from Bambalapiti to Kalaniya, there's a route you should go, right? So you are able to go in that route? Maybe no. So we know where we should go. Okay, we take the bus and we go in that bus and we get down to some place and then we go in another bus and go home. Fine. Similarly, if you are okay with this, we are able to do these vectors very easily. Now we'll move on to example. Here we are at Shakti. Okay. Here we are at Shakti Institute and I need to go to, for example, let's say Kandy. So what are the ways we can go to Kandy if we are using the public transport, not our personal vehicles? If we are using public transport, what is the, where should we go first? Railway station. You are going in the train. Oh yeah, you can go to the train. If we are going in the bus, we can go to the Colombo bus stop, and then we have the Kandy bus. So from here we get into a bus and we go to Colombo. So we have buses here. We called it A, and we have a bus from Colombo to Kandy. We can call it B. Now we don't have a direct bus from here to Shakti to Kandy. No. We don't have us like that. No. So what we do is we go from here to Colombo and then Colombo to Kandy. Fine, right? So we write an expression like this. I am at Shakti. I need to go to Kandy. Okay. My original location is Shakti. My destination is Kandy. So I am moving from Shakti to Kandy via Colombo. So I go from Shakti to Colombo. I go from Shakti to Colombo, and then from where to where? From Colombo to Kandy. So keep in your mind this. We started from Shakti and we have to end from Kandy. So here also we started from Shakti and we should stop by Kandy. Fine. Right. Now we'll consider another thing. We have three places. Okay. We have three places. This is A, this is B, this is C, and this is D. So we have vectors here. We'll say buses. Okay, we have three buses like this. Now I need to go from capital A to D. How do we move on from capital A to D? What do? We start from A and then move to B, from A to B, and then we go from B to C. We go from B to C and then from C to D. Are you all okay with that? Now see, we started at A and we need to finish at D. Here also we start at A and finish at D. And this, here we are finishing at B and starting again at B. So these two must be equal to each other. Here the same, we are finishing at C and again starting at C. So these two must be equal to each other. Are you okay with that? Fine, right? Right, so I can write SK is equals to, from Shakti to Kandy is equals to, the vector here is simple A and the vector here is simple B. And here we can write the vector here is A and this B and this C. So the vector AD can be written as A plus B plus C, and here the vector SK can be written as A plus B. Are we okay with that? Understood, right? You can do this addition. Fine. Right. So we'll write to the topic, right? Right. Just write this down. SCK. And we'll write the second example also. A, B, C, D, and we have to find the vector A, B. Right, so I'll write a few examples here to start these questions. Right, we have the vector P, the points P, Q, R and S. Okay, this is given as simple A, this is given as simple B, and this as C. And you are supposed to find the vector SQ and the vector RP, SQ, RP, and the vector SP here. Okay, so make sure you write this capital letter notation. After that you can move on to simple letters. Right, so start this question 1. and question 2. Here you are supposed to find the vector AC and the vector BD and the vector AD, BE and AE. Okay, we'll start these two questions. Right. So we'll start from the question 1. We have SQ. So we are supposed to find SQ, RP and SP. So make sure you write the capital letter notation also, the sum of the vectors, and then substitute the values with the simple letters. Right. So here we can start from SQ. So SQ is equals to, so SQ means this vector. Right. So SQ is equals to SP plus PQ. SP is simple A and PQ is simple B. Next, the vector RP. So we can write RP equals to RQ plus QP. The vector RQ is simple B and the vector QP is simple C. Okay. Next, finally the vector SP. So to find SP we can write SP equals to SR plus RQ plus QP. So SR means simple A and this is B and this is C. Right, and the next, the vector AC. So we can write AC equals to AB plus BC. So the vector AB is P and the vector BC is Q. Next, the vector BD. So BD equals to BC plus CD. So the vector BC is Q plus R. Next, the vector AD. So AD equals to, the vector AD equals to AB plus BC plus CD. So AB is P, Q and R. And next the vector BE. So BE we can do something like this. So instead of writing all the 2 points again, we can write BE like this. So BE means, now we have already found BD. So I can write BE is equals to BD plus DE. BD plus DE. Right, so BD is already been calculated, so BD means Q, Q plus R and DE is simple S. And finally AE. For AE also we can do the same thing. We have already found BE, so I can write AE is equals to AB plus BE. Just look at you are fine with that. Instead of writing all the 4 points again, since I have calculated BE now, I can write AE is equals to AB plus BE. Fine, right? Okay, so here we write AE equals to AB plus BE. So AB is simply, this is B, not simply P. AB is P, this is Q, R and S. Is that correct? Okay. So that is the addition of vectors. Right. Next we have something different. Just write the topic, reverse vectors. Next, write the topic, reverse vectors. Reverse vectors. Okay. So now here, just look into the board. We have a vector capital AB. We have a vector capital AB. So I write the vector AB is equals to simple A. The vector AB is equals to simple A. Now if we move on to the theories, we said a vector has a magnitude and a direction. So What is representing the direction of this vector AB? Who represents the vector? The direction rather. The arrow, right? So which means the direction of the line AB. And what represents the magnitude of the vector AB? The length of the line. That's what we said. Now we need to find the vector BA. Do you see any relation between the vector AB and BA? If so, what is the relation? Now we discussed about the vector AB and it is given as simple A. We need to find the vector BA. So my problem is, my question is, do we have a relation between the vector AB and BA? If so, what is the relation? Multiply by negative sign. Okay. What is what I refer is, now we have something called magnitude and direction. Here also we have something called magnitude and direction. Is either one of them equal to each other in this? Yes, what is it? Direction? The magnitude. Fine, right? Now what I said was measuring the length of the line from A to B and B to A. Both are the same. So the length of the line AB and the length of the line BA is equals, which means the magnitude of AB and the magnitude of BA is equal. So magnitude is equal. What about the direction? Is it different, or can we use another word for that? Rather than saying different, now different means this. So here we have direction and this is also another direction. So these are different directions, that's fine. We can use another word, better word than different. Opposite. Are we okay with that? So AB is from here to here and BA is directly opposite. So the opposite vector with the equal magnitude of AB is called the BA. So if AB is simple A, we can write BA as minus A. Just multiply it by minus 1. Okay, so we call this as the reverse vector of AB. Are we good with that? We'll move on another example. Okay, we have a point P and Q and this is simple B. So the vector PQ is simple B and then the reverse vector of PQ is known as QP. What is the vector QP then? Minus B. Are you okay with that? Right. Just write this down. Below that, right? A vector with equal magnitude, and opposite direction. A vector with equal magnitude and opposite direction is called the reverse vector of any given vector. Is called the reverse vector of any given vector. Right. So just draw this diagram and below that write the vector AB is equals to simple A and the vector BA is equals to minus A. The vector AB is equals to simple A. The vector BA is equals to minus A. We'll write this example also. So we have PQ which is B, then QP is minus B. QP should be minus B. Right. So now we know the addition of vectors and the reverse vector. Right. So now they have given a question like this. We have 3 points A and B A, B and C, A, B and C, right? The vector AB is simple A and the vector CB is known as simple B. So the vector CB is B. And you are supposed to find the vector AC. Now the thing is this, when you are writing that vector addition, don't mind about this arrow. I mean, don't mind about direction. If there is a vector on that particular line, you can move through that. That's it. Fine? Right. So I need to move from A to point C. I have to go from point A to point C. What is the route we have to use? From A to B and B to C. Okay, so I write this as AB and BC. Make sure you don't change these signs. So we do nothing here. We just write what we did previously. Okay. So what is the vector AB? The vector AB is simple A. You can write simple A. And what's the vector BC? That is minus B. So here you write minus B. Fine, right? So the final answer should be A minus B. That's it. Are we okay with that? Right, just write this down. Right. So we'll draw another example. This is capital A, B, C and D. Here we have simple A. This is B and this is C. And you are supposed to find the vector AC, the vector BD and the vector AD. Start this now. So here you have to find the vector EC and AD, AC, EB and finally BC. So in this example we can write, okay, AC is equals to AB plus BC. AC is equals to AB plus BC. So the vector AB is simple A and the vector BC is minus B. And the vector BD, so we can write BD equals to BC plus CD. So BC means minus B plus C. And finally the vector AD. So AD is equals to AB plus BC plus CD. So AB is simple A and this is minus B and this is plus C. Just check whether the answers are correct. For AC, BD and AD. Yeah, you can change, that's fine. Okay? What's the question? Okay. So the order of writing the simple letter, you don't mind about that. So you can write anything. The order of writing the capital letters are very important. Okay, the ones who have finished this example start this. So here we have another question and you can simplify this, okay? This is A, B, C and D. The vector AB is 3A. The vector DC is simple A and this is B. Here you are supposed to find the vector AC and the vector BD and the vector AD. Right. So we'll write EC. EC equals to ED plus DC. So ED is R minus S and AD, the vector AD. So we can write AD equals to AE plus ED. AE is minus Q plus R. Right. And then the vector AC. AC equals to AE plus ED plus DC. So the vector AE is minus Q plus R minus S. And EB. Right. So we can write EB. The vector EB is equals to EB equals to EA plus AB, and this is Q plus P. Finally the vector BC. So BC equals to, since we have already found AC, I can write BC equals to BA plus AC. So BA is minus P and AC is minus Q plus R minus S. Okay with that? Right. Then we'll try the next example also. So in that example, since we have two vectors in terms of A, you can simplify that. For example, if you get 3A minus A, you can simplify it and write as 2A. Okay? Right, so here we can write AD, no, initially AC. So AC is equals to AB plus BC. AB is equals to 3A minus B. And next we have BD. BD equals to BC plus CD. So BC is minus B minus A. And then AD. So AD equals to AB plus BC plus CD. So here the AB is 3A and BC is minus B minus A. So the final answer should be 2A minus B. Is that the answer you get? 2A minus B. Right. Okay. Next we'll write the topic. Equal vectors. Next we'll write the topic equal vectors. Equal vectors. Okay, the thing is this. Now, in that example we discussed now, all the examples we had around 3 to 4 vectors. We had simple P, Q and R. Now here also they have given this. This is 3A and this is A. But in our exam questions, they won't give all the vectors. I mean, in all these sides, they won't give the vectors. Only 2 vectors would be provided. Only 2 vectors would be provided, and so we must be able to find the remaining vectors in terms of A and B and then write the addition of vectors. Are we okay with that? Okay, so to do that, what we do is we have to study about this equal vectors, right? We'll start from here. So in the start we said vectors has two properties. One is the magnitude and the other is the direction. Okay. Now if I say example, a man is moving towards north with a velocity of 50 meters per second, and a man is moving towards south with a magnitude of 50 meters per second. Are these two velocities equal to each other? Other velocity, we'll write it. The man is moving towards west with 50 meters per second. Are these two velocities equal to each other? What do you think? Is it equal or not? No, it's not equal. Like, for example, if you start from here, from a point, one person move towards north and the other towards west. For like after a time of 3 seconds, the first person would be standing here and the second would be standing here. So these are not equals. But I can say the speed of this and this is equal. The magnitudes are equal. Are you okay with that? So then for two vectors to be equal to each other, what must be the condition? What should be the condition for two vectors to be equal to each other? Both of them should be equal to each other, which means the magnitude and the direction should be equal to each other. Okay? Right, now we'll consider a square. So we'll come to a question in our format. We have a square which is called as ABCD. Now can I say, now since it's a square, all the four sides are equal. Now can I say the vector AB and the vector AD is equals to each other? Can we say the vector AB and the vector AD is equals to each other? Can we say that? No, we can't say that. Why can't we say that? Because direction, a different direction. Then what must be the equal vector to AB? The equal vector to AB is DC. The equal vector to AD is BC. Are we okay with that? Right. Now we are moving on to a trapezium. Now we have a trapezium, here also we have a trapezium, but we'll do another different one. Okay, we have a trapezium which is PQRS. This is P, Q, R and S. Now can I say the two vectors PQ and RSR as they are equal to each other? No, we can't say they are equal to each other. What is the reason we can't say that? Because the length of the line PQ is much more greater than the length of the line SR, right? So the magnitude of PQ is greater than SR. Even though they are in the same direction, even though their directions are same, their magnitudes are not equal, which means the two vectors are not equal. Fine, right? Okay, so the condition for two vectors to be equal to each other is both their magnitude and the direction must be equal to each other. Fine. Right, we'll write like this. Let us topic equal vectors below that, right? If two vectors have equal magnitudes and equal directions, if two vectors have equal magnitude and equal directions, equal magnitudes and equal directions, then the two vectors can be considered as equal. Then the two vectors can be considered as equal. Right. Okay, so this is what happens in the exam question. They would be giving us this square. We'll start from this square. So they have given us the square and they say, so they don't mention any vectors here. No mentioning of the vectors in the diagram in the question. And what they say is, right, the vector AB is simple A and the vector AD is simple B. We find the vector AC and BD. This is the question. Exam type question. Okay. So initial they have given us two vectors. The vector AB is simple A. I can write this as simple A. And the vector AD is simple B. Okay, right? And next what you have to do is make sure you mark all the equal vectors before starting the calculation. So do we have any equal vectors to AB here? No. Yeah, we have. What's the equal vector? It's DC. The equal vector of AB here is DC. Fine. Any equal vector to AD? It is BC. Alright, so make sure you mark all the equal vectors, and now you can start finding these vectors. So what is AC? AC is equals to AB plus BC. Okay, right? What about BD then? BD is equals to BA plus AD. Are we good with that? So make sure you write all the equal vectors and then start the calculation. Right, just draw this diagram. We'll write a small question like this. In a square ABCD, write a small question. In a square ABCD, the vector AB is simple A and the vector AB is simple A and the vector AD is simple B. The vector AD is simple B. Find the vectors AC and BD. Find the vectors AC and BD. Okay, just write this question. Write the vectors AC and BD. Okay, so I'll write two questions. Question 1. This is a parallelogram. This is P, Q, R and S. So this vector is simple P and this is S. Here you are supposed to find QS and PR. So here, when we are finding, we are supposed to find AC. So AC can be written as AC equals to either AD plus BC. Or else you can write it as AB plus BC. Find AC equals to AB plus BC. So AD is simple B and BC is simple A. AB is simple A plus B. This question. This is a parallelogram when they have given us two vectors P and S. We are supposed to find QS and PR. Let's go find QS and PR. Right. Because this is the second question. We have a square ABCD. We have a square ABC. And here they have given this is simple A and this is simple B and this vector is simple B. That's all they have. Now you should find the vector AC and CE. Find the vector AC, CE, FD, AD and EB. So here we can write, so this vector must be P and this vector is S. Initially we are supposed to find QS. So I write QS equals to QS is equals to QR plus RS. So QS is simple S and RS is minus P. So just check whether your answer is correct. QS must be S minus P. Right. And PR. The vector PR can be written as PS plus SR. So PS is simple S and this is P. So if you're done with the first question, we'll move on to the second, and if you're done with that, we can move on to the third. So the third question is something like this. Question 3. Sorry? Yeah, so those are in question 3. We have two parallelograms combined together. Two parallelograms combined together. So in the third question, in the question they must be given either we write as so here we write the equivectors, this is equal A and this is equal A, this is B and this is B. The vector is, so we can write AC equals to AB plus BC. This is simple vector. And then the vector CE. CE is equals to CD plus BE. CD is B and minus A. FD. We can write FD equals to FC plus CD. So FC is simple A plus B. And next we are supposed to find the vector AD. We are supposed to find the vector AD. So AD is equals to AB plus BC plus CD. The vector AD is simple A and this is B plus B. So here the right answer is A plus 2. A plus 2. Next, we are supposed to find the vector EB. So you can write EB equals to EF FA AB. So EF means simple B and this is simple B plus this is equals to A minus 2. So let's check whether the answers are right. That should be AE and BF AE. This should be, I'll write it as BD, not AD, it's BD. Okay. So we have finished the second question. Just go through your answers and see whether the second question is correct. Fine, right? Okay. Okay, so don't skip these capital letters, okay? Make sure you write the capital letters also. Because now this is a quite easy one. Now when we move forward, we have few fractions coming up here. So the best thing is you write the first capitals and then with the simples, okay? Right, so question 2 is done. We'll move on to question 3. So this is question 3. Okay, this is A, B, C, D, E, F, G and H. This is A and this is 3A. This is B and this is 2B. Right. Okay. You are supposed to find H, F, B, G, C, H, B, E, A, D, G, E, G, E, G, D, D, H. Okay, start this now. Okay, so what you have to do is initially write all the equal vectors, mark all the equal vectors, and then we can consider the addition of vectors. Thereafter we can consider the addition of vectors. This is D, this is D, this is C and this is C. Okay. So we can find AE initially. So AE is equals to AB plus AE is equals to AB plus BE. So AB is D plus C. And BF. So the vector BF is equals to BA plus AF minus D plus C. And next AD. So we write AD equals to AF plus So here we can write HF. The vector HF is equals to initially the equal vectors. Mark the equal vectors first. So this is A and this is A. Here this is 2B and this is B. This is 3A and this is B. Right, so I can write HF equals to HG plus GF. HG GF. So HG is minus B, rather plus B minus 3A. Right. And BG. So BG equals to BA plus H plus HG. So this is A plus 3A plus B, which is equals to 4A plus B. Okay. Right. So BG is also calculated. Now CH. CH. So we can write CH equals to CB plus CB plus CB is minus B. So is the vector CH 4A plus minus B. Yeah. Finished. Okay. Right. Next, so I have to complete this. I have to remove there. For the ones who have finished this, so make sure you write the capital letters notation. The second is you should simplify this. Don't leave this as it is. Just simplify. Take all the letters of A together and letters of B together. Okay. Right. Now we move on to hexagon. Now hexagon is a different story. So this is our fourth question. Right. We'll start from here. So in this way you should mark all the equal vectors initially. Right, we'll consider this as simple A and this is the center and this as simple B. Okay. Right. So here you should find OB. OB and FA. OB, FA. And we have FB, FC, yeah. So the question 4, that's a regular hexagon. Regular hexagon, so all the sides are equal. Right, so I'll finish this out. Here we have BE. So BE equals to, we have already found BG, but that's irrelevant for this. We can write BC plus CF plus FE. So BC is simple B plus A plus 2B, which is equals to A plus okay. So in the hexagon, this is what happens. You should consider the parallelograms within the hexagon. Now, how many parallelograms can we construct here? If I consider A, B, C, O, this is a parallelogram. When I consider this parallelogram, what are the equal vectors? This is equals to this, and this is equals to this. Can I find this? You can't find this directly. You should find the vectors. You should start with the sum. But if I consider the parallelogram A, B, C, O, I can say this is simple A and this is simple B. Okay? And similarly, if A, B, O, F is considered, then what is the vector you can find? This is A and this is A. Fine, right? Okay, so what you have to do is find the vectors within, rather consider the vectors within the parallelogram and then write the vectors. Consider the parallelograms within the hexagon and then mark the equal vectors. So don't think that, okay, this is a regular hexagon, so all the vectors must be equal. No, that is not what we meant. We said if two vectors are equal to each other, then the magnitude, both magnitude and the direction must be equal to each other. Okay, so again what I say is, just mark only the equal vectors. Now for example, in this hexagon, we don't know what BO is. So since you don't know BO, you don't know AF, you don't know F, then you don't know OE, and then you don't know CD. Okay, just mark only the equal vectors. That's it. Sorry. This EF. Okay, so initially we'll mark the equal vectors. So considering the parallelogram A, B, C, O, this is equals to this. This is A. This should be B. And when we consider this is equal to this anyway. This is A and this is B. FO, this FO is also simple. FO is also simple. Right, I will start from OB. So we can write OB equals to OB equals to OA plus AB. So OA means minus A plus B. So OB is minus B. Right. The next is FA. So we can write FA equals to FO plus OA and OA is minus B. Okay. Right. Next we have FB. We are supposed to find FB. So from F to B, you don't know this vector. We can write FO OA AB. So FB is equals to FO right, FB is equals to FO OA AB. So FO is simple A and OA is minus B and AB is plus A. So this is the answer we get for FB, 2A minus B. Okay, right. Is that correct? Right. Next we have HC. Where is H here? not H, FC. FB is calculated, now FC. So FC is easy. FC can be written as FC equals to FO plus OC. So this is A plus A, which is equals to 2A. That's FC and EF. So EF is of course easy now. EF is minus B. Finally CD. CD equals to CO plus OD, which is minus A plus B. Are these answers correct? Just check the final ones. Is CD okay and this FB fine, right? Okay, so draw this diagram. So here all these three lines are equal. And we are supposed to find these vectors. JO and OD, IO, HD, IC, EK, JD. So initially mark all the equal vectors, write down all the equal vectors, thereafter you can find the given vectors. Right. So we'll start from this now. So in drawing this, the easiest way is, so the ones who didn't see how I do it, so the ones who saw it, I think you all can manage it. Initially draw the hexagon. And thereafter attach the four parallelograms. Initially draw the hexagon and then attach the four parallelograms. Okay, so we'll start from JO. Before that, we have to write the equal vector. So we'll start from the horizontal ones. So all the horizontal vectors can be written as simple A. So this is A, this is A, this would be A, this is A, this is A, and this is A, this is A, this is A, and this is gonna be A, right? And this is B. This is B, and apart from that we can consider this vector as B, and this vector as B, and this vector as B. So these are the equal vectors we have in the diagram. So that's it. Now we can start finding the remaining vectors. Right. So we write JO. So the easiest way from J to O is moving through A and K. So JO is equals to JA plus AK plus KO. So JA is simple A, AK is simple B plus A. 2A plus B. OD, so the vector OD equals to OL plus LD, so OL is simple A plus A, this is 2A. Right. After OA, we should find IO. So I also can be written as IO. IO is IK plus KO. So IK is simple A plus A equals to 2A. And HD. So from HD we can come from this route and then here. So HD equals to HG plus GF FE ED. So HG is simple A plus A minus B, which is equals to 3A minus B. Right. So move on with the remaining. Right. So then after HD, so you don't have enough space, I'll write the final answer there. So IC from I to C, the answer should be IC. 3A minus B. Is it 3A minus B? IC? Yeah. Right. And EK. So the vector EK is equals to, so we can write EK as, EK means minus 3A minus B. Is it minus 3 minus B? Okay. And finally JD. Where is D? Okay, JD is 4A plus B. 4A plus B, JD. Is it so? Right? And DI, where is DI? Okay, DI is minus 4A. Fine. Do you all get those answers? Okay, right. Questions? You may consider minus 1 as a contract. Yeah, so minus 1 into 3a plus b. Fine. Okay, so are you all okay with vectors? Fine, right? Shape nene buluwan awlanne. So next, so apart from this, what we have to do is like something like this. Now in the exam you don't get this much bigger diagrams, but the thing is we would be getting something like this. They would be giving us a point. Now see OAB, and C is a point on AB, and they would be giving us a ratio, and we are supposed to find this. So that is the next thing we have to discuss. So we are now we are able to find AB, but the problem is they are giving us a point on AB which is called C, and the C divides AB to the ratio of 3 to 1, and we are supposed to find OC. So we'll discuss these type of questions by next week. Okay, right. So that's enough for vectors. We'll move on to polynomials. Let's take the polynomials too. Right. So since we have newcomers, we'll just go through the theory we discussed last week and then do some questions. So the ones who joined today will share you all the recording of the polynomials. And so I think we have done polynomials for around 4 to 5 classes. Just go through the recording, then you all can have a rough idea of what we have done. Right. So this is where we stopped. So the ones who were present last week. When we divided fx by x minus alpha, what was the remainder we get? F alpha. When we divided fx by f alpha, we obtained a remainder called f alpha. What is this theorem called? The remainder theorem. So we have a theorem called the remainder theorem. The remainder theorem. So there what we said was when you divide a function fx by x minus alpha, the remainder is f alpha. Okay, so the newcomers, this is what we do. We call these type of expressions as polynomials. So we have much more to learn. But for now, expressions like x squared, 3x plus 1, we call them as polynomials. And this is a notation we study under functions. So we have not covered functions, but we had a brief introduction to functions before we started polynomials, and we have functions yet to be covered. Okay? Right, so what we do here is, in this notation, when you are asked to find the value of f2, it means just substitute x equals 2 here. So similarly, substitute it to the function also. Are you all okay with that? So what if you have to find f0, what should you do? The newcomers. This is the function fx, and you are supposed to find f0. What should we do? So if f2 means substituting x equals 2 here, no? f0 means substituting x equals 0. That's it. So you can write 0 squared 3 into 0 plus 1. Fine, right? What about f minus 1 then? Minus 1 squared 3 into minus 1 plus 1. Do you all get that? Are you fine? You are okay with that? What about you? Shid, Avlan, are you okay with this? You do, Shid, right? Okay, so this is what we do. We'll do some questions regarding the remainder. Okay, we'll few more examples. What is the remainder we get when we divide px by x minus 1? When you divide px by x minus 1? P1. So newcomers, what you do is just equate this to 0. You get x equals 1, substitute it to the polynomial. So remainder is p1. Fine. We have a function qx and you divide it by x plus 2. What must be the remainder? So we equate this to 0, we get x equals minus 2, and substitute it here, the remainder is q minus 2. So the remainder should be q minus 2. Okay? Right. So we'll write this question. Question 1. They have given us a polynomial fx equals to x cube ax plus 10, x cube ax plus 10, and they say the remainder when fx divided by x minus 1 the remainder is 2. We are supposed to find A. We have a polynomial. We have polynomial fx equals to x cube ax plus 10. You divide it by x minus 2 and they say that the remainder is 2. We are supposed to find the value of A. Oh.